Welcome to part 3 of our DxEnterprise demo series. So far, you've seen us demonstrate high availability of a native SQL Server instance to our 2-node mixed distribution Linux cluster and 4 different containerized RDBMS instances. This section will show you the capabilities of DxEnterprise on Windows and how you can easily manage your highly available Windows and Linux clusters from one unified management interface. I'm going to start by opening up the DxAdmin GUI on my Windows 2016 virtual machine. From there, we want to connect to the local singleton cluster on this node. Then we want to join this node to the cluster we previously created in parts 1 and 2. So we'll type in the target IP address, and then we'll also insert the passkey that was previously established. So right here you can see on the tree view, we have 3 nodes in our cluster now. We just need to use the connection manager to add our final Windows Server node to the cluster. So again, we're going to go down to cluster membership, and we're going to use the IP address for our existing cluster. Throw in our passkey, accept the EULA, and submit. So now you can see we have a 4-node cluster containing our Red Hat Enterprise Linux and Ubuntu node, as well as 2 additional Windows Server 2016 nodes. Next, we want to add some workload, so we're going to start by managing some storage. As we go to do this, you'll see some red boxes to show the nodes on which certain disks are not presented. We did not present any of our disks to all 4 of our Linux and Windows nodes, since we only need our vhosts to be able to span their respective platforms. The infrastructure agnostic nature of DxEnterprise means that whenever application vendors release cross-platform integration for Windows and Linux, we will be able to rehost and manage failover between the 2 platforms. I'm going to speed this section of the demo up again, since you've seen these steps quite a few times already. But once we take care of this, our next step is going to be to create a new vhost. Just going to make the tree view a little easier to look at. And our new virtual host, we just want it to be able to run on Windows. So those are the 2 nodes that we will add to it. Then once we submit that, our next step is just to associate our disk to that vhost. And now it's time to add a native SQL Server instance to the vhost. And you can see when I open the drop-down that we already have 3 SQL Server instances installed across our Windows nodes. But I'm going to go ahead and fast forward through the rest of this process. You've also seen it quite a few times. So after clicking OK and yes, we just have to wait a few seconds for our green dot to appear in the upper left. And there it goes. So with that, our SQL Server instance is now active and running normally on our Windows Server node. So you can see the details here of the SQL Server 2014 Standard Edition. And you can also see here in the instance view that we now have 2 native instances listed, both our Linux and Windows Server instances that we've added to the cluster. But the next thing I'm going to do is go through the familiar process of managing another disk to use with our Windows Server OSs. The next thing I'm going to do is create another vhost that can run on our Windows nodes. Just like before, we need to give it a host name and an IP address, and then add our 2 Windows nodes for the vhost to be able to be active on, switch up the ordering, and click submit. So from there, I just need to associate my storage to the new vhost I just created. And with storage associated to our vhost, we are now ready to add our first Windows Docker container to the cluster. In this case, I'm going to choose another containerized instance of Microsoft SQL Server, but this time, this will obviously be a SQL Server on Windows instance. I'll go ahead and speed through this process. Should just be a few more seconds. So there, the green dot changed, and that means we now have a containerized SQL Server instance running on our Windows Server OS 1 node. Just like native instances, containers can be easily manually failed over, and they can also be automated with performance policies and thresholds. DxEnterprise will also take automated action if anything breaks, the operating system, application, or an infrastructure outage. In addition, intelligent smart availability technology makes sure that your workloads are operating where they can perform at the highest level, ensuring their best execution venue 24/7. But with that, our demo is complete. You saw DxEnterprise's full capability to manage native and containerized instances in a mixed distribution Linux cluster, and you saw how easy it is to unify Windows, Linux, and Docker under one highly available management framework.